Hi, my name is John. Welcome to another Sunday night nightcap. In the first part of today's nightcap, I make a plastic blanking plug for that water steam separator I made, some screw cutting on the lathe. I do a pressure test on that, find the actual leak it's got, weld it up and get all that sorted out. In part 2, I machine a car first motion shaft, gearbox first motion shaft, to take a repair sleeve for a bearing. I went for a walk this morning, beautiful early morning walk. I took my camera with us. I got a little bit of film of an area not far from my house that's always had problems with flooding. Show a little bit of that. As some viewer mail comes in, one or two interesting items, one really interesting item, and I'll show a little bit of that. In last week's video, we made this water steam separator, and I filled it with water and let it stand for a little bit to see if it had any leaks, and I noticed in editing the video there was a very slight weep from down there. So what I've decided to do, I can blank those two off, and I'm going to make a blank to screw into there and put a bit of air pressure in, not a lot, 10-20 psi air pressure, and just make sure all these welds are sound, because once it's installed on the boat I don't want to have to be taking it off and then have to do it again. I haven't got an 1.25" BSP blank, so I'm just going to turn that bit of plastic down, screw that into there, put some air pressure on, and then soapy water will find any leaks, just like finding a leak on a bicycle tyre in our tube. So first thing to do is get some thread geometry. I know it's 11 teeth to the inch, 11 TPI, teeth to the inch, that's for saws, you thick twat. 11 threads to the inch. I'll have a look on the internet and get some dimensions, and then we'll cut the thread. These are the change gears in the back of the lathe, and I need to change, I think it's just that gear there. I've got a chart which shows the various threads. We're going for 11 TPI, which is that one. Need a 50, driving a 63, fasten to a 40, that's your ratio to convert the imperial to metric, driving 120. At the minute I've got 50, 63, 80, 120, so I need to change that gear. Those two gears are key onto that shaft. That's the key way. At least that's the key in there. So you want a 40 tooth onto there. That's the 40 tooth gear. It's a gear I made, and I made it out of fibre because it's quieter. Also, if you crash the lathe and jam things up, it'll simply strip the teeth off that gear, as opposed to doing any major damage. Right, so now we've got to get these two into mesh. I think we should have loosened that nut off before I put the big nut on. Now I've got it. Right, so that drops into there. These gears are noisy, they always are noisy, straight cut gears. Set that one up first. A little bit of backlash in them. You never have them binding, otherwise they make terrible noises. It's not too bad, a little bit of backlash. And they've still got plenty tooth contact. You hear them clattering about, it's nothing to worry about, you just don't run them fast, that's all. You loosen off this bit here, which is called the banjo, lift that up, that into mesh with that one. That is definitely a 120 on there, yeah. They're all noisy, they're terrible rattly things, but it's just going to be going slow, so that'll work fine. little bit of lubricant on there. I use slidery lubricant because it's a nice sticky greasy oil. I sometimes use motorcycle chain oil as well, but that'll go quite nicely. That's an important oil point on there. Oil's that shaft. Right, ready to go. This is the gearbox on the lathe, and this being a 140 version, it's got that extra lever there. There's all the horses have only got the 2 levers. So if I look at my chart, we want 11 TPI. So it's showing me those 2 levers go to the left, that lever goes to the right, and that goes 1, 2, 3, 4, 5th along. So we'll go 1, 2, 3, 4, 5. Down to that one. Those 2 to the left, and this one to the right. And that should cut 11 threads to the inch. That's that one there. So we've got 2 to the left, we've got that in the right place, and 1 to the right. 1, 2, 3, 4, 5. See how this is graduated, it's all metric, and obviously we're trying to cut imperial, and that's it locked in. And I found some sizes on the internet, 1.25" BSP, 11 threads to the inch. The major diameter, that's the outside the threads, is 41.9, we'll call it 42. And the minor, which is the inner core of the thread, like the tapping wheel size, 38.952, so we'll call that 39. Right, so it's 42 minus 39, so it's 3 mil aside. 3 mil thread depth. Get this round and measure it. So we want 42 mil, we've got 44. 1 mil cut should sort that out. 1 mil per side. .42 dead, then we'll need 39. That's at 40. I'm going to put a half mil cut on for that bit. That's it. Right, so when the tool, screw cutting tool touches there, that's the full depth of the thread. I put a little recess in the end of there, or it'll not do any harm. Right, so we've got a 55-degree tool using that fishtail gauge. You can tell why it's called a fishtail, I suppose. And that lines up nicely like that, so it means the tool is square to the job and it is dead on centre height. Normally you would cut the thread on the compound slide, advance it like that, so it basically only cuts on that edge. But for a thread and plastic, I'm just going to go straight in. It's not going to put that much load on the threading tool. This being a metric lathe, an imperial thread, once I start, I'll have to leave the feed nuts engaged. Right, I'm going to put a little bit of cut on, just a scratch cut, just to mark it. Made 11 TPI gauge looks pretty good. I can see better through the camera lens than I can when we roll the repeaters. That looks pretty good. We'll settle for that, I think. So we need to wind the tool out, reverse the lathe, back into 0, and a bit cut, a good bit cut, half a mil. And then forward again. There's a friend of mine who does quite a lot of big threads, important threads on bronze bar, and he uses plastic to set his machine up and get his tools right. When your tools start thread on a valve spindle, and a piece of plastic's cheap where a piece of bronze is a fortune now. So it's a good bit of practice as well. So wind out, one full turn, reverse the lathe, back into 0, little bit of cut, lathe forward, see how the cut's getting broader and broader as we're going, because I go cutting on both sides of the tool. You wouldn't be able to do this with steel or even brass. Just engage the lead screw. Right, so that screws in there quite nicely. A little bit of pipe tape on there and that'll seal. In fact, it will probably seal on that face if we screw it all the way down. Like that. Right, so we'll put some fittings on, or put a gauge on, put a bit of air in and see what sort of leaks we've got. I know there's one little one there. A bit of PTFE tape on the threads. That's a fitting I made for testing some steam valves I'd made. The machine 2 flats on it, so I didn't have to resort to heathen methods like that. Anyway, right, want a pressure gauge on one of these, and then one rear valve in the other one. Then we can put a bit of air in. It is, and there's a fit in here to put a pressure gauge into. This is the one I use for testing the oil pressure on the jet engine. Right, so we've got a pressure gauge all blanked off. We'll try and get some air into it. Not a great lot of pressure, don't need much pressure. If I wanted lots of pressure, I'd be using hydraulics. But some would be nice. That is going in, it's going up. Lots of more air we're putting in. It's 10 psi nearly. That'll probably do actually. So now we need some soapy water on all these welds. The pressure is dropping, so it obviously has got a leak. It could be out of one of these fittings, out of that valve, I'm not sure, but I think it's bleeding back slow. There it is. We'll get some soapy water on the job and put a blank on there and go from there. Right, I found one leak, little defect in that weld. Well, there's lots of defects in the weld, that's why I'm not a welder. But that's the leak there. You can see it plain as day, bubbling up, one little pinprick there. The rest of it is all good. Where I thought was leaking from down there wasn't. All these seams are excellent. So we'll just, this is just soapy water, so we'll mark that one point and just run the TIG round and just fill it that little bit in, and that'll be the job done. I'll test it again, but I'm pretty sure that's going to be it. That blanking plug will come in handy. I'll probably drill it and tap it quarter for doing various fittings, but that's not pissing out, but it's leaking. The weld's pretty good actually. It's quite a respectable weld, except that one bit there. And everything else quite nice. And then one bit there. I'm not making excuses, but I'm trying to weld over the camera, which doesn't make matters easy, but that's a simple fix. I'd rather fix it now was have the lad come back and say, John, it's pissing steam everywhere. It probably wouldn't show up because there's no pressure in here. It just exhausts to the atmosphere. I've welded up the offending leak on there. And I've also put a straight outside valve in so I can get the pressure in a lot easier. We'll put some air in. Right, that's just over 1 bar pressure in there. I'll get some soapy water and we'll see if we've managed to cure the leak. Right, that's the place that was leaking. And now it's not leaking. Happy with that. If it was leaking it would come up like frog spawn. Pretty good. The place I thought was leaking actually wasn't, just that one little weep there.